Hello my dear students. So in the today lecture what we'll do, we'll take one design problem and going to solve that problem step by step. Okay, in the previous two lectures I explained what is Gantry Girder and what are the different types of loads that is to be considered. So what is the percentage if it is manually operated, electrically operated. So how much you have to take, that is discussed in the previous lectures. Okay, so today I will take one problem, so accordingly we can discuss this one. Okay, so first I will read the question. Okay, so before solving this problem, the diagram should be in your mind. So then only you can solve this problem. Okay, so design a gantry girder supporting an electrically operated crane to the following data. So what is the capacity of the crane? That is 250 kilonewton. So what is the meaning of this one? Means by using that hook, how much it is to be lifted? Means 250 kilonewton it is lifted. Okay, so capacity of that hook. So and next one is what is the span between the crane rails? Span between the crane rails means which one is that one? So if you are seeing this the previous diagram, so if this is the truss, so this is the span. Okay, this is the span between the crane girder, crane rails, that is how much? 16 meter. Okay, next self weight of the crane girder means what is the thing if you are observed. Okay, so this is the girder what you are seeing now. So self weight of that crane girder is 150 kilonewton. How much that is? 150 kilonewton. And weight of the crab electric motor and hook is how much? Is 50 kilonewton. Minimum hook approach means 1 meter, means minimum hook approach is 1 meter. And the wheelbase is how much? That 3.5 meter distance between two. Okay, so wheelbase is how much? The 3.5 meter. A span of gantry, that is span of gantry means along this direction. Means along this direction, what is the span of that gantry? That is how much? That is 6.5 meter. Along this direction, that is 16 meter. That is 16 meter is the span of crane girder and span of the gantry is 6.5 meter. So you should take a note of this one before solving the problem. This question should be in your mind. How means one picture should be created in your mind, then only you can solve the problem. Okay, now we'll solve the problem step by step. So in the step number one, what you're supposed to do means we are supposed to calculate the maximum wheel load. So means what is the load that is coming on the wheel? How? Okay. So first thing is the what is the capacity of the crane? The capacity of the crane capacity is how much? That is 250 kilonewton is the capacity of the crane. And plus 50 kilonewton. What is the 50 kilonewton? This is the weight of crab or trolley. Means what is the maximum load that is coming on the wheel? That is total 250 plus 50 is, that is 300 kilonewton is, that is the load that is coming on that wheel. So always we are supposed to multiply the service load. Okay, so it with 1.5 in order to increase the working load should be multiplied. Okay, so it is with 1.5 means already you have to take factored load to design. Okay, so that's why I multiply with 1.5 into 300. So how much the load is coming on? That is 450 kilonewton. This much of load is coming on that wheel. So next again, so for one thing you have to take a note of this one. So whenever you are designing this, so I will show in the diagram. So here, so if you are designing this girder, so you have to take all the loads that is coming on this one. So if you see this one, what are things it is coming? So here means how much hook capacity is given, that is 250 kilonewton. So this is to be where it is to be transferred. Finally, it is transferred to the girder. No, so this 250 kilonewton is given and is given next. That's weight of this crab is given. That is 50 kilonewton. Where it will go? Again, it will go to the support. That is 250 plus 50. That's 300 kilonewton is this one. Next apart after this one, which load? The weight of this gas crane girder is also going to transfer. No, so that's why we have to take the self weight of this one also. It is where it is transferred. It is also transferred on this girder only. So we have to take all the loads that is without means all the loads that is rested by girder. It is to be taken, and for that maximum load, we have to design the girder. Okay, so this picture should be in your mind. Huh? Okay, so these are the things it has been done. So that's why. So here what happens? The is given self weight of crane girder is 150 kilonewton. Again, it is to be multiplied with 1.5. Where it is multiplied? We have to take factor load. So how much? The 450 is the static load, and again the self weight of the crane is 225 kilonewton. Okay, so usually self weight. Okay, so this is 450 kilonewton is the load. So can anyone tell me where it is to be placed? Okay, so usually in the question itself he is told the hook, the maximum it can maximum hook approach is 1 meter from the support. So that's why means maximum reaction when it is going to come on this girder. Maximum reaction कब आएगा? When it will come? So if 450 kilonewton is if it exactly at the center, what is the load is coming on this RA and RB? So it is 50 is going to come on this side. That's 450 by 2, 450 by 2. So means we have to check at what place of this girder so maximum reaction is going to develop. So whenever if you want to design any structure, any member, we have to design the members or we have to design the section for the maximum load. So that's why means maximum load means if you want to increase the reaction of this one, how will going to increase? Means you have to take the load near to the support. You have to take this load near to support. Means how much maximum distance we can take? Because in the question itself it shows maximum hook approach is 1 meter means so what I will place? I will place this 450 kilonewton. This hook load that is means what is the lifted that is means up to 1 meter. So this 450 kilonewton I will place at distance 1 meter. In the question if it is given 1.5 meter, you place it 1.5 meter. If it is given 0.9 meter, you place it 0.9 meter. So this is placed at here. So next is 225 kilonewton. This one is placed exactly at the center. Why? Because it is sulfate of the crane girder. It's like a UDL. So where it will be placed? It is exactly at the center, na? So sulfate is given the directly to 25 kilonewton. That's why it is exactly at center. So this is the diagram what you are seeing. Okay, so I think this is a simple thing. So this is the simply supported beam. So RA, RB and vertical 450 kilonewton is the crane capacity and 225 kilonewton sulfate on this. For this one, what we are supposed to do means here we are supposed to calculate the reaction RA and RB. How we are going to calculate this RA RB? So I will apply the condition of equilibrium and I will solve the problem. So what I will do? I will take moment about A is equal to 0. Moment about this A is equal to 0. So already you are aware. So if you study this is the basic part. Okay. So moment means force into perpendicular distance. What do you mean? What is the meaning of this one? Moment I will calculate force into perpendicular distance. You take one now I am here considering anti-clockwise as positive and clockwise as negative. Okay, so let's start with this one. So RB is the force and the perpendicular distance I'm taking moment about it. So perpendicular distance is 16. So RB into 16. So how it is rotating? It is rotating anti-clockwise. So I am taking moment about A means this RB is the force and what is the perpendicular distance 16. If it is rotating anti-clockwise, so that's why it is first. It is positive. Okay, so next time going this course is over. Okay, always start don't while doing examination first we will take 450 after 25 don't do that then come from one end and consider all the forces. Okay, so next this is over. Next I will go with this one. Yeah, that is 225 into what is the distance into 8. 225 into 8. So 225 into 8 means so how it is rotating. So if you see the arrow mark it is rotating clockwise. So that's why I am taking negative sign. That's what is written negative sign. Next 450 into 1. Very good. 450 into 1. How it is rotating? It is rotating clockwise. That's why I am taking negative. So please don't make it confused. You take 1 plus 1 negative. I am taking anti-clockwise positive and clockwise negative. You can take clockwise positive, anti-clockwise negative. It doesn't matter. So we'll get the answer same. Okay. So okay, we'll move for this one next. So if we'll solve this one, that is I will take 16 RB is equal to my 225 into 8 and 450 into 1. I will add these two and I will take that side. So 2250 is the answer 16 RB. So RB is equal to 2250 divided by 16 means so finally I am getting RB is equal to 140.625. This is the value what I am getting. So this is the usually what is the condition of equilibrium? Condition of equilibrium you are already studied that is summation of MA is equal to 0, summation of Fy is equal to 0 and summation of Fx is equal to 0. Okay. So these are the condition of equilibrium. You can use these condition of equilibrium and you can calculate a support reaction. Okay. So one part has been calculated. RB has been calculated. So I need one more equation to calculate RB. So which one you want? Summation of Fx or summation of Fy? So I will go with summation of Fy. So summation of Fy means what? Algebraic sum of all the vertical forces. If force is going upward, if force is going upward, I will take plus. If force is going downward, I will take negative sign. Okay. So for this one, so if you are saying here, so I am written, uh, uh, say R is going upward, so it is positive. Okay. And 450 is going downward, minus 450, minus 225 plus RB. That is equal to 0. What I have done? Summation of Fi is equal to 0 I have taken. Fi means algebraic sum of all the vertical. So I have written Ra plus Rb, I have written this side, and 450 minus 225 taken that side. So if you take that side, so what happens? If you go for this one, 420 Ra plus Rb is equal to 450 plus 225. After that one, Rb I have taken that side. Rb value has been calculated 140.625. If you substitute in this one, so what is the value I am getting? This is the reaction, that 534.37 kilonewton. This is the reaction what I am getting. Means I got the value of Ra as well as Rb. So Ra how much I got? 534.37. So this is the maximum reaction that is experienced by support A. Means when the maximum reaction, when it is coming, when the load is at a distance of 1 meter. So this, for this load I am supposed to design. Okay. So means the reaction from the crane garden is distributed equally on the two wheels. Usually the wheels are how much? That is two wheels, no? So that's why it should be divided by 2. So 534.37 divided by 2 means 267.18. The load is going to transfer on each wheel. How much? So 267.18 is coming for one wheel, and for the other wheel 267.18. Okay, so this is your step number 1. So remaining part we will discuss in second lecture.